We're just finishing worksheet 6, side A, and then we're going to take the pre-assessment today. I have those copies you asked for, okay?
I just woke up this morning, I'm like, no, I'm so excited.
Woo! Pre-test!
I barely got any sleep.
Okay. Alright guys, the only definition we didn't get to yesterday was sector. A sector is a piece of birthday cake, it's a slice of pie. Okay? When you take a circle and you cut a chunk out, so it has a radius here, and an arc here, the area in here, okay, is a sector. Now, it's not really a piece of cake, because cake would be a three-dimensional thing, so that would have volume, not just, yeah. But you get the idea. That's the shape we're talking about. The area of a sector, the formula we're going to use is 1/2 r squared theta. Is that at the top of your blue sheet? Can you look?
Yeah.
What else does it say at the top of the blue sheet? Inventory. Oh, just put it away. I never really check it all over very carefully. Thanks. You rock. What else does it say, though, on there and somewhere? I don't know that it's bolded, but it does say theta must be in radians. So this formula only works if theta is in radians, okay? And what we get out of this, then, is the area of this sector. So it will be in square units of some kind. Everybody good? All right, so we get a quick question on that. It says, Jaden is making a round garden. Guess she's just bored, wants to make it a circular garden. The radius is 10 feet. What area does she have for tomatoes? What do we know about tomatoes? 50 degrees. They're round, they taste good, okay. We need to find the area, so we're going to do 1/2 r squared theta. But we're going to do 1/2, what's r for this question? 10 feet. Times, what do we have to use for theta though? Yeah, so we got to do this times pi over 180. Can we, since we're just going to type it in anyway, can't we just not reduce it? And I mean, it would be 5/18, but just type it in. 0.5 times 100 times 50 pi over 180. Anybody get a decimal?
43.
I as well got 43.6 square feet of area for her tomatoes. Anybody not getting that answer? Everybody all right? Instead of 50, you're good?
This is the hardest thing we're going to have to do.
Or of a sector? Yeah, it's not, they're not complicated. This one says wildflowers. What do we have to watch ourselves on here, though? There's 2 of them. One of them doesn't tell us how big it is. There's those weird angles that go together, also known as, when they're across from each other, vertical angles. Vertical angles. Okay, so by vertical angles, this is 80 degrees and 80 degrees. So we have a total of 160 degrees of arc. Yeah, I know. It is not to scale. So we have 1/2. Our radius is still 10 feet squared times our, when we switch it to radians, we get 160 pi over 180.
Actually,
Are my times looking like decimals? I'm sorry. Are we okay?
no, it's not.
What? Be 20 feet across. Maybe she used to have a pool and it killed all the grass, you know, big circular. Yes. Because there was 80 degrees of wildflowers over here and another 80 degrees of wildflowers on this side of the circle, that's where we got the 160, okay? Good question. All right, if 6 ounces of wildflower seeds can cover 10 square feet, how many ounces of seeds does Jaden need in order to plant all of the wildflowers? Any ideas?
Well, you
How'd you do that?
we could do dimensional analysis and use that as a conversion factor.
Okay. Yeah, I would have set up a proportion. But if you divide this, you get 13.96, but it's not per 1 ounce, it's for 6 ounces she needs of that, so you'd multiply by 6. I would have totally set up 6 ounces will get me 10 square feet, so 139.6 square feet needs X ounces. I would have totally done a proportion. No. As long as you get the right answer. What am I doing here? Okay, there we go. Sorry. Everybody okay? Oh, answer? 80. So she needs to buy about 84 ounces. Okay. What is going on here? Stop this. All right. Read this to yourself and tell me what this number represents. Yeah. As far as I know, if you had some kind of propeller or that shape for a wind turbine, the 27.1 on that single blade would be the radius. Does that seem okay?
Yep.
The blades are turning at 28.5 RPM. Find the angular speed and the linear speed to the nearest tenth. We did. What kind of label does angular speed have to have? Radians per time. So how are we going to change this to radians per time?
Change the revolution converted to by.
Now, do we have radians per time? Anybody type that in? What's 157 pi? 28.5 times 2 is 57, I think. Yes?
It's 179.
All right, then they want the linear speed. Anybody remember how we can convert? Multiply by? Gonna need their formula sheet for this stuff, I can tell. Okay. So 57 pi times 27.1 is 4852. What did you get if you used the rounded answer? Did I type something wrong?
You did like 485.
Yeah, it's 4850 something, and then it depends if you use the whole 57 pi or the 179 thing. I wrote down the rounded one here, so I'll go ahead and write 3.6. I don't really care. As long as I can tell what you did, you're fine. Label?
Meters per minute.
Does radians magically disappear?
That was really bad. Why doesn't that happen? There has to be some videos somewhere.
You find
It.
it.
Our notes, guys, no, our notes at the beginning of yesterday said right here that arc length and radius, the angle theta is defined by arc length divided by radius, and they are both in the same linear units, so therefore it is unitless. We call it radians, but it's really unitless. Are we on 14? Or did I skip one? Okay. Centrifuge. Everybody good? Know what that thing is? It spins real fast up in chem? Okay. 400 pi radians per second. What is that?
That's the RBM. RBS.
It is an angular velocity because it's already in radians. Unfortunately, for some reason, they want us to switch it back to revolutions per minute or RPMs. We can do that. It's just dimensional analysis. Radians per second. What do I need to do? Okay. 2 pi radians is equal to 1 revolution. Now, this is what always gets people when they try to do it on their calculator, because remember, you put a 2 pi in the denominator, you need parentheses. I would just reduce it. 400 pi divided by 200 pi, it's going to just be 200, right? But we also want minutes, so we got to do what? Okay, I need seconds to cancel and minutes to wind up down here. Yeah, I need 60 seconds is 1 minute, so we're going to multiply by 60. I have to write it down so that it makes sense to me. You just multiply, divide, I go. All right, what do we end up with? Yes. Jared is already on the next question. He says find the linear speed. So we need to use 8 radians, but which number are we using? Yeah, remember this one has to be in radians for this formula to work. So we need to use the 400 pi radians per second. Or we could change it to minutes if we wanted, but times a radius of 8 centimeters. It doesn't specify the labels, so I'm good with just leaving it per second. What do you think? 400 times 8 pi would be 30, or times 8 times pi would be 3200 pi, but it's like 10,000 and something, right? Okay, or I could put an extra 0 in there. Label? Centimeters per second, yes?
Yep.
Good job. All right, 2 more? 3 more? 2 more questions? Okay, a flywheel mounted on a crankshaft has a radius of 6 inches. That's pretty clear, radius 6 inches. It is running 2,800 RPMs, which is revolution per minute. And they want the linear velocity. If I just put this question on a test, I'd probably just ask you the linear velocity and be done with it. When we're all done here, this wants it in feet per second, which is a whole nother ball game. But for now, let's just find the linear velocity and then we'll convert. How do you find linear velocity? This has to be in radians. Good call. So it's 5,600 pi radians per minute. Then what? Yep. You multiply by the radius. So we're going to... Yep, doesn't matter when you convert it. Okay, what are the two conversions we need to make it feet and seconds? Inches down, feet up. Do you know that conversion? 12 inches. Yep, is 1 foot. So we're going to divide by 12. What else? We need it to be seconds. 1 minute is 60 seconds, so we're going to divide by 60. I know. It's like... So if you were typing this in, if it was me, I would type the whole top in, and then I would type the whole bottom in, and then divide it, so I didn't get confused. Okay, 5,600 times pi times 6, and I do all that. And then I do 12 times 60, because those are both in the bottom. Oh, did I miss one? No, I didn't. Okay. And then divide it. But anybody get an answer?
I don't think it's right. 146.6.
Yeah, it's 146, I think, something, isn't it? And label, what labels were left at the end? Inches, inches, minutes, minutes, feet per second.
Yeah, right.
Okay. I'm thinking if I asked you to do that question, it would have been fine in inches per minute how it started. Okay? But it just got to read the question carefully. It might ask you to convert. Never know. All right. Last one, and we're going to skip part A. Sorry. Kristen's working ahead, I can tell. A toy racing car is traveling on a circular track that's 3.2 meters in diameter. What's the first thing half you're going to get wrong? Yeah, we only want the radius.
Well, I'm glad you have confidence in us.
I would never. Good job. Okay. 0.31 radians per second. I'm really excited because what kind of an answer is that? 0.31 radians per second. It is an angular velocity already in radians per time, right? So how do we find the linear velocity? It's always one or the other. It's just throwing it out there. It's angular velocity times radius. So it would be 0.31 radians per second times 1.6 what? Meters times, look at guys, kilometers per hour. They never just let us be, right? Anybody? Well, actually, do we need to do seconds to minutes and then minutes to hours, or you know the 3,600? Okay. I just don't want to confuse anyone. There's 3,600 seconds in 1 hour. Meters need to go on the bottom, kilometers on the top. 1,000 meters is 1 kilometer. Okay, so everything's on the top except for the 1,000. 0.31 times 1.6 times 3,600 divided by 1,000. 1.8 kilometers per hour. All right. That's it. Now you need to do this. Next week's quiz on Tuesday does not have this stuff, okay? This stuff is on the quiz after that. Still do a homework check, because then we're going to just kind of practice it. All right.